Okay, since electronics ang pinag-uusapan natin dito because we're dealing with sensors which we need to digitize, which we need our computers to control, let's talk about linear versus non-linear in electronics. Again, review, di ba? Pag linear, ang input-output curve ay straight line lamang. Yun lang, napaka-boring niya. Straight line lang talaga siya, input versus output. And no other better example than our ohmic materials, di ba guys? Ang input mo ay current, ang output mo ay voltage, ang slope mo ay resistance which is constant kapag ohmic ang material. All right? So here is an example. Okay? Nonlinear system, anything but a line. So in electronics, maraming ganito. And the input, kasi dito, di ba? Ano yung input natin? Posibleng voltage ang input, current ang input, output ay voltage, no? Pero posibleng kahit ano to, especially guys, pag sensors na yung pinag-uusapan. We will be dealing with very interesting sensors na ang input, for example, ang input mo ay temperature, ang output mo ay resistance. So may tinatawag na resistance dependent, temperature dependent resistors, TDRs, temperature dependent resistors. Nagbabago yung resistance depende sa temperature, di ba? So may mga ganon. So the input axis could be, for example, temperature. The output could be resistance. Marami ganon. Alright? So posible ring hindi linear yung input-output curves nila iba-iba. And these are just examples of anything but a linear curve. Okay? Again, how about another way of describing whether, or rather determining if a system is linear and nonlinear is by differential equation. Alala niyo yun? Basta, ito to, like this. Paano pag yung input mo changing in time, no? Like ito, pag linear yung system, voltage is proportional to current, vice versa. So, ibig sabihin, pag nagbabago yung voltage in time, nagbabago rin yung current in time, and proportional sila. And the proportionality constant is the resistor, right? Ibig sabihin in circuits, di ba? Pag kunyari AC, yung signal mo, may resistor ka dyan. Yan. Tapos yung measure yung current pumapasok dito, I of T. Yan. Tapos constant ang R. No? So itong I of T, proportional lang. Kung itsura ng B of T, kamukha rin ng I of T. No? Posible lang may konting amplitude change or phase change, especially pag sine wave to, kunyari AC. Yan. Pwede rin direct current, no? So, yung source mo is constant voltage. No? Ito kasi kanina AC, ito naman DC. So, baterya yan. Okay? So, you have constant current as well. Tapos resistor rin. Yan. So long as the resistance is constant, and that's true for ohmic materials, then you have a linear system. Okay. So, pag linear system, one of the most linear system, let's talk about linear passive components sa electronics. Kanina, ang pinag-usapan natin is yung mechanical system. So, ang linear components niya ay yung spring, yung mass, at saka yung damper. Okay? Yung influence nila is just described by a constant, right? M, B, and K. Sa electronics naman, yung mga linear passive component. Passive, ibig sabihin ng passive, a resistor won't need to work, it doesn't need the power supply. Unlike amplifier, to work, it needs its own power supply. So an amplifier is an active component while a resistor is a passive component. So we're talking about a linear, which is an ohmic, and passive component. No? So resistor is one. Okay. Yung resistors, pwede silang iba-ibang materials. Ano? Pwede siyang conductor. Okay. Kasi ang resistor, pwedeng bakal. No? May resistance, inherent resistance sa mga bakal. No? In fact, nagiging proportional sa haba, sa cross-sectional area ng bakal, yung conductivity niya. The inverse of conductivity is resistivity. Okay? Mga insulators din, pwedeng maging resistors. These are dielectric. So just dielectric is just a fancy word for insulator. And then there are semiconductors, those exotic materials that are between conductors and insulators. They are actually insulators that are doped. Okay, and depending on the electric fields impinging on them, they can be either conductors or insulators. All right. So, for example, you have the sources can be there's an electric field or there can be a battery. Basta the electric field influences the movement of the charge carriers, right? All right. And in this case, actually, pag sinabi mo yung current pag ganito, actually yung electrons papunta pa in the opposite direction. Ang convention lang natin, guys, di ba? The nakasanayang convention is from the positive terminal of the battery to the negative. Yun yung direction ng current by convention. Pero sa totoo lang, ang nangyayari is this part is an electron source, and the electrons, when there is a conductor attached to the positive end, is actually the electrons are influenced or forced to move towards the positive. So ang gumagalaw always in a circuit is the electrons, all right? Electrons. And we know that kapag negative ang charge, repel, and positive negative plus positive na charge is nag-a-attract. Okay? And alam rin natin na kapag the force in among charges is given by this, no? Okay, Q1, Q2 over R squared, and there's this vector there. And this part here, okay, Q1, R2 can be expressed as a field, right? All right. Yung ating first experiment, actually gagamit tayo ng resistor, guys. Okay? You can actually reconstruct a resistor via wire. Ang tawag doon, wire wound resistor. So, example, meron kang bakal, a metal wire. Okay? So, may cross-sectional area siya. And all metals have a lot of free electrons, valence electrons. They're free to move about. That's why they're conducting it. Free yung electrons nila to move about. Okay? All right. So, any material is said to have a conductance. And the conductance is just the inverse of resistance. Ang units ng resistance ay ohm, and its symbol is the omega. And the conductance is mho. Alam niyo ba to, guys? Binaliktad lang yun. Parang toki, no? Ikot ng toki. Binaliktad lang yun. So, conductance is mho. Okay. The conductivity of any metal wire, okay, the conductivity or the conductance is proportional to its cross-sectional area, length, and the temperature of the wire. And kaya natin gawin siyang compact if we wind it into a coil, right? Making sure na usually this is first lacquered, meaning dinalagyan siya ng layer of non-conducting film like acrylic para pag nag-touch yung wires, hindi magko-conduct bago i-wound into a coil. So you make it more compact. The longer it is, the more resistance you have. Okay? Okay. So we know that V is equal to IR and I equals 1 over R of V. So we can express as that current is equal to conductivity times V. Okay? Marami yan. Can be, for example, our resistors, yung mga carbon compound, ito yung mga typical na resistors na gamit-gamit natin. Yun may mga color bands pa. Okay? Alright. And the uses of the resistors, of course, is to control current, for heating, for reducing voltage, and together with other linear passive components can induce phenomena like resonance and damping. One use of the resistor, of course, is to control the current para hindi. For example, LEDs are very sensitive pag sobrang taas ng current na dumaan sa kanya, you can burn it or you can destroy it. So one way of controlling the current passing through is by using a resistor. You're also familiar, parang review na lang to, no, guys, but you're familiar about computing resistors in series and parallel. You know this very well, right? Okay, so just pass through this. And of course, you've been using Kirchhoff's rules, I think, in your previous classes. But I'd like to emphasize one use. Paulit-ulit natin itong gagamitin, guys. And this is the voltage divider. And again, please pay attention kasi ito yung first experiment natin, ano? The voltage divider is a circuit that looks like this. You have a source, V in. It need not be DC, but for this example, it's DC, no? Oh, by the way, okay pa kayo? You understand these circuit diagrams? I'm assuming kasi sanay na kayo sa circuit diagrams. Comments naman dyan. Oy, any reaction about, naintindihan niyo ba itong circuit diagram na to? Hello?
Na-discuss pa sa 181.
Okay, cool. All right, so malinaw sa inyo yung ibig sabihin nito. Okay, reviewing the voltage divider. May dalawa kang resistor, right? R1, R2. You have a voltage B in, current I. Since this is a single loop, passes through the system. And you're going to tap B out this way, dito, between the resistors, R1, R2. Okay. Now, ang tanong is what is B out? B out. Okay. Una muna, B in should be equal to whatever is the voltage across R1 plus the voltage R2. And then from Ohm's law, we can say that invoking Ohm's law, we have V equals IR. So since iisa lang yung I mo throughout the circuit, B in is equal to I R1, which is VR1 plus I R2. You can factor out I and sum together R1 plus R2 is equal to V in. Okay, so ang tanong, what is V out? V out essentially is the voltage across R2. V out is essentially the voltage across R2, which is just I R2, where I, given by this equation, is V in over R1 plus R2. And therefore, V out is simply R2 over R1 plus R2. Now observe, if R1 is very small, it's very less than R2, then V out is approximately equal to V in. Okay? If R1 is very much smaller than R2. If R1, on the other hand, is very much greater than R2, then V out approaches zero, or it's a small voltage. Okay? And now, guys, this is our first element. In our first experiment, we will use a potentiometer. Essentially, if you open a potentiometer, it's actually just a wire wound resistor, just like this. There are three legs to the potentiometer, and this is one of the ends. This could be 1 or 3, and this is 3 or 1. No? Basta yan yung magkabilang dulo ng wire wound resistor sa loob nito. The 2 is kung saan mo man dinadaan yung contact. This knob here is actually a contact point, conductor, and it's touching the wire at different points in the circle. No? So essentially, ganito it's a variable resistor. A potentiometer is a variable resistor. In symbols, it looks like this. Mali yung numbering ko dito. This should be 1, 3, and this should be 2. Sorry guys. 1 and 3. And itong gitna ay 2. Sorry. This is so wrong. 1, 3, and 2. Okay? Okay? So you can use that as a resistor. And by adjusting the position of the knob, or rather rotating the knob, parang inagalaw mo, pinapalitan mo yung ratio between R1 and R2. Kasi this one, kung nandito siya, so ganito lang kahaba yung wire wound resistor on this end, and ganito naman kahaba yung wire wound resistor on the other end. Alright? So kumbaga, essentially, this is R1, R2. By connecting a potentiometer to a voltage source, you actually can produce a simple voltage divider. Ta-da! And therefore, you can control V out using a potentiometer. But what's crazy is this. Do you know that in our first experiment, this knob is rotating, right? What if we attach a ruler here or a stick here, no? So kapag renotate natin siya, mag-iiba yung voltage. Renotate natin yung stick na yan. Therefore, pag magro-rotate ito, iba-iba yung voltage, iba yung voltage. What if we use the potentiometer as a rotation sensor? We can measure angles, guys, using a potentiometer. Imagine mo, mag-stick ka ng popsicle stick dito sa knob na to. Okay? But what we need to do is we first have to calibrate. I mean, if you measure this voltage out, what angle is that? If you measure this voltage out, what angle is that? And we will have, therefore, an input-output curve. Okay? The input is the angle and the output is the voltage. Oh, ha? So this is our first experiment. So hopefully you get your Arduinos next week, and we'll talk about how we will make this into a rotation sensor. Okay? Hanggang dyan na muna. Okay?